Okay, here's the multiple choice problem. When synthesizing the following alkyne, which carbon-carbon bond should be made to give the product in the best yield? Now, this wasn't the original question. The grammar just has been reworded so it's actually proper English as opposed to whatever it was that I wrote before. So the idea is, which of these carbon-carbon sigma bonds is the best one to make in order to make this molecule? And so when we're making alkynes, the way to make an alkyne is, say, for example, we choose A. We make the alkyne by reacting a halide, like a bromide, with the deprotonated terminal alkyne. So if we make this so if we're making A, this is the combination that we would use. Then we have to decide, is this reaction feasible? Well, we have a good nucleophile, so it can do SN2. It's also a strong base, so it can do E2. That, on the other hand, is an sp2 carbon. Bromines attached to sp2 carbons don't really do SN2 reactions. This gives no reaction. So bond A is not the bond we want to try. So that takes care of A. Let's take a look at B. Well, if we do B, we do the same thing, except now we put the anion on this carbon, and we put the bromine on this carbon. Now, since this is the alpha carbon, we have to invert it. So instead of a wedge deuterium, it's a dash deuterium. And this molecule here can do SN2 and E2. This carbon right here, it's a primary carbon because that deuterium is the same as a hydrogen. Primary carbons do SN2 reactions. They do E2 in the case of bulky bases. This is not a bulky base, so it can do the SN2 reaction. So B is a possibility. Let's take a look at C. We're making C. Bromide goes there. Carbanion goes there. Here's your alpha carbon. So in an SN2 reaction, we want to invert the alpha carbon, so we make that into a dash. This can do SN2 and E2. This secondary carbon can do all of them, SN1, SN2, E1, and E2. Well, SN2 and E2, SN2 and E2. You will get some of the SN2, but the major product is likely to be E2. So that eliminates C as our possibility. Last option, D. So there's a carbanion there. There's a bromide there. Again, we can do SN2 and E2. this. This is tertiary. Do SN1, E1 and E2. This is going to give a majority of E2 products and not our target product, so D is out. So we've eliminated D, C, and A, but B is still a possibility. So B is our choice. And if we wanted to actually draw the starting materials of it, that reaction to make that alkyne, it would be these two.